One of the questions that I get asked quite a lot is SDL, or the Security Development Lifecycle, from a Microsoft perspective, is something that we can do as a product development company. And it's something that is somewhat specific to our environment. And there's always the question around how do we help customers apply that in their environments where their business is quite different, the types of application they're building are quite different, and the types of attacks they have are quite different as well. I think one thing I would say, though, that there is a very, very large and growing interest from customers around secure application development. And we're seeing more and more that we're getting a lot of questions from customers in this area. We hold pretty regular CSO councils where we'll reach out to our customers and just their security organizations and understand what their concerns are. And one of the #1 requests that we get is actually absolutely around information or help with the security development lifecycle. And one of the biggest problems or concerns there is I guess what we call the asymmetrical problem. And this is, for many organizations, you have a very limited amount of time to get a line of business application out. You have a very limited resource pool to do that. And once it gets put out into production, the bad guys who are going to attack it pretty much have, as long as you leave it there and as many resources as they care to throw at it to actually attack you. And what makes it even worse is that you may find 10, 100, 1,000 issues in your application. They only need to find one, and then you've got a real problem. So a couple of key questions. How do we implement SDL in a programmatic manner? There's all sorts of issues and I think things that block SDL deployment in organizations. And I guess secondly, what tools or processes do we have that can help scale out the process of getting to this state of secure development, more secure development? So there's been a whole bunch of different activity that we've had from an Australian perspective around the security development lifecycle. And this has been everything from working with partners to helping them define security certifications where they can make statements about the process they use to develop the software and I guess get some additional value when they talk to their customers about how they develop the software. Also working with academia and working with them to understand how we can actually introduce this into undergraduate programs. Because I think one of the issues we see is that you really want to get people aware of the issues around security and development from a very early stage. And then working more directly, I guess, with some of our enterprise customers on how do we actually get their architects and their senior developers aware of what's happening from a security development lifecycle perspective, what the issues are, what the concerns are, and going the next step and actually implementing the security development lifecycle in the methodologies that's used inside these organizations. And I think across all of the different organizations that we've dealt with, which has ranged from financial services to telecommunications to the government space, there's a variety of experience that's really specific based on where the organization's coming from, what concerns they have around security and what they see as their threats. One of the things we can look at when I look at the security development lifecycle that Steve had up a little bit earlier is where most organizations start. And really that's with a whole series of reactive measures. The application is pretty much built, and at that stage you're making the decision of, am I going to do some penetration testing because I'm worried about the application, or I've had some breach and I need to respond to that in some appropriate manner. What we're absolutely seeing as we go through this is, I guess, a series of stages that organizations making decisions to go, I guess, one step and then multiple steps towards implementing the security development lifecycle. And this all starts with, very, very basic stuff like training and awareness, where all you're trying to do is get people understanding what the issues are and get them sort of, I guess, making the right decisions. All the way through to dedicating a security team, so you actually have someone who has a bit of an independent role to play here, who can make some assessment of what's going on, and then going into a much more controlled process around actually using these practices we're talking about today in your methodologies, and making decisions from a release perspective that you won't release something unless it meets the criteria you've talked about. Across all of this, obviously, there's a range of organisational change required, a range of cost required. But what I would say is, regardless of whether you just start with just training or you actually decide to go the whole hog and implement a full-blown security development lifecycle, where you will actually not release software unless it's done in an appropriate manner, there's benefits to be had at all levels of this. So some key things that we've had, I guess, in talking with customers around this has been some things to think about would be one, executive buy-in. And in general, most organisations will start with very low executive buy-in. maybe they're interested in just doing a little bit of training, or maybe not even that. In many cases, the issues aren't really well understood, and it's usually only after a breach has occurred or something's really bad gone wrong that we actually see organisations really sort of gearing up in this area. Second thing to really think about is the degree to which you can have good separation of responsibility, which I think then comes back to how structured your processes are in-house already, and also whether or not you can have a separate security function that can deal with the applications. And finally, to what extent can you actually mandate changes on the development teams, which is, it's always a bit difficult to actually get people to, I think, across an entire organisation, think about, let's do this additional processes, let's take these additional steps that may actually make my project take a little bit longer to get to production, or may mean that a certain feature no longer is something we can release. So to go through some of these issues in a little bit more detail, what I'd like to do is to introduce you to David Palmer from Westpac Bank, which is an Australian bank. It's one of what we call the big four banks in Australia, a very large bank. It's a full services, financial services organisation. So it does everything from dealing with retail consumer customers through to high net worth customers, investment, funds management, corporate banking, basically the whole range. And they have about 8.2 million customers. So they actually, in terms of the threats against the organisation, it's not just monetary loss, but they have a very significant place in the Australian economy and business world. So there's significant reputational losses, as well as storing a lot of personal identifiable information. So they really have potential issues across the board. What makes that a little bit more difficult for David in his role is Westpac has, as many large organisations do, a very complex and heterogeneous environment, broadly distributed geographically. So there's about 800 sites that Westpac has across the area of approximately the contiguous United States. And on top of that, they've got a really significant online presence, incorporating both consumer and corporate online banking. And it's actually at the stage now in Australia where banks will put more transactions through their online channel than they will put into their branch. So they have some really high threat applications that are pretty broadly exposed. So with that, I'd like to introduce David to come and talk about some of the issues he's dealing with from a customer perspective.
Thanks, Adam. That's great. Hi, everyone. David Palmer. I'm from Westpac Bank, heading up the information security risk management team. The slide on there. Just to give you a bit of background on what I do, our team, information risk management team, is involved in projects that are spawned within the business of Westpac, and we get engaged early in the process to review for compliance to information security standards, policies and guidelines. We've got three teams, one of which is my team, that make up the information security group that reports to the Chief Information Security Officer. The other team is the Security Governance and Strategy. They look after information security policies, standards and procedures. And we have a Technical Security Services team. They have responsibility for reviewing new security products and reviewing, well, that could be hardware and software products. And also they're responsible for network security architecture as well. Why is SDL important to Westpac? Well, Westpac business is banking, and banking is built on trust. And for our customers, trust is very important. We need to maintain that level of trust, and to do that, we need to take steps towards that maintenance. Because otherwise, if we don't, well, we could lose that trust with our customers through a security compromise of a software application. We have, as Adam mentioned before, we had a large internet presence with our retail internet banking systems and also with our corporates. Within the industry, there's a lot of concern that criminals may switch targets from the normal phishing attacks that we receive on a daily basis, I don't know what it's like here in Australia, given that we have 4 to 6 banks. Mainly it's the 4 major banks that are targeted by phishing attacks. It's really a 1 in 4 chance or opportunity for the criminals to use email lists with .au suffixes on the domain name to send emails, and a 1 in 4 chance of reaching a customer. The financial services industry relies upon each other in the secure transfer of interchange files between banks, between Visa and MasterCard, and we need to have secure applications to do that, and also to implement cryptography correctly to do so. ISO 17799 compliance. Does anyone not know what ISO 17799 is? Okay, ISO 17799 is an information security standard that is an assurance that an organisation is providing confidentiality, integrity and availability within their processes within the organisation. And also it deals with the protection of information security assets, and those assets extend down to the software level also. Just to give you a bit of a story about why we're looking to comply with this information security ISO standard. We have been approached by a number of state government departments in Australia seeking that a certification of compliance to the standard. If we do not have this certification to the standard, which provides these governments with state governments an assurance to the level of security that we have on our internet business-facing applications, they won't do business with us. So, and that came about as a Premier circular. I know you have governors here which head up your states. In Australia we have what's known as Premiers. So the circular came out, and for us to get business, we need to seek compliance to ISO 17799 standard, and we believe following SDL will assist us to move to obtain the certification. And look, I can understand why organisations would want to seek a certification, and that is we were looking at a third-party software vendor providing a, well, actually not we. This was for another organisation I was working for, not Westpac, so I'll just get that straight away. That they presented to us an internet-facing application to do money market transactions, whereby dealers would be able to log on via an SSL connection and also having a client digital certificate. And this was demonstrated to us. It looked really good. Data was being protected to allow trades to communicate to the back-end ASP-hosted web server. Authentication provided by the digital certificate on a smart card even. Absolutely fantastic. The business was jumping out of their skin saying, look at the security. It's absolutely fantastic. And upon closer inspection, we discovered that there was one certificate on each smart card, and it was the same digital certificate with the same passphrase to activate the certificate that all of the dealers would know. And it gets worse. It gets worse. Just by simply viewing the source of the authentication page on the login screen of the website, and this goes on from what Michael said before about his little story about authentication with the cookies. This is even better, Michael. You'll like this. They maintained authentication using the hidden variable field within the web page. And clear text, you could see the person's login ID and the person's password. So all that another trader had to do to put trades under another trader's name was to view the source of that page, and then they would be able to get access to put through trades under that person's name, because they had a digital certificate on the card. It was known by everyone. It was all the same. So, yep, you can conduct fraud securely through an SSL channel. Fantastic. Okay. And is it a standard practice for us at Westpac for SDL? Not at the moment. We're taking small steps as we go. And another reason why we're doing it is cost. It's so much more cost effective to implement security at the very beginning of a design process, right at the, I guess, the conceptual point of getting our developers to think security. How can we make this application, this service more secure? Because it's like at the end of the project, someone coming up, and I think it was Keith Brown on Monday, saying, "Okay, the application's in. Just turn the security switch on now, will you?" And you go, "Huh, what? What security switch? It wasn't implemented in the project plan." And then you have to go back and do all your hacking and modifications to implement security, and then the security is then not woven into the application as well as it should. So we are hoping to make savings by putting the security in up front. We've also got some regulatory drivers pushing us down the SDL path. Sarbanes-Oxley is a big one. For Westpac, well, Sarbanes-Oxley is the management assessment of internal controls. Sarbanes-Oxley came out of the US government's, I think it was legislation to require more stricter auditing requirements on companies. Given Westpac's an Australian company, we have representation in this country, the USA, with an office in New York. So therefore, we have to comply with Section 404, the internal controls assessment. And by doing that, we have to, well, not we, but our executive management have to provide an attestation to the level of security and internal controls for the production of our financial reports. Another one is the Basel II, or as it's also known as Basel. I've heard it called Basel as well. It's a town in Switzerland where this accord is produced. There was a Basel I back in the late 80s, and now we've moved on to Basel II. This framework is for risk management, and it allows the banking organisations to maintain an amount of capital that they have, money, against a level of risk that they have within the organisation. So if you can, through risk management processes, show that your level of risk is low, it means then the amount of capital that you can hold to offset the risk can be low as well. So therefore those funds can be used for other things within the organisation instead of just sitting in the bank to cover off any event that might require some capital injection of funds there to cover off a compromise or a fraud there. So that's another driver. If we can have secure development processes in place, that would then aid us to reduce our level of capital against the risk. Internet-facing applications. Yes, we've got we've got plenty of them, and there's many more on the drawing board. And any time you expose an interface to the internet, then you really do need to take a look at that interface quite closely and attempt to reduce the level of risks that may be sitting on that interface. We've got so many projects on the drawing board that are going to be using internet-based technologies that we're going through them with a fine-tooth comb. And also the bank in general is going through a process of overall risk reduction too. Increased attacks, phishing and software virus. With the phishing, as I said before, there's a 1 in 4 to a 1 in 6 chance for the criminals to issue emails to take advantage of our customers' I guess naivety, you could say. Software virus, well, that speaks for itself. What practices we're doing now? Well, we've already put our developers through security development lifecycle training. We already have in place and signed off by our executive management as of the 1st of August, I believe, our new information security policy, and we're going through and rationalising most of our standards within the organisation for our developers to follow. We also conduct internal and external penetration testing, and we don't just rely on our own staff to do that. We go and get our organisations that we have a trust relationship to do that on our behalf. Security and risk team engagement on projects. Well, that's us. That's the information security management team at Westpac. I have 2 managers and 4 senior consultants who engage with the different business units within Westpac to assist them to do business more securely. We also do many risk assessments for those businesses. And we also perform code and peer reviews also. For the future, we need to scale out the use of our tools, FX Cop and the like, and we need to adopt a more formal threat modelling process. What you saw with Michael's presentation there is excellent stuff, and we don't go into that level of detail, but I can certainly see by following that we would gain benefits from it. How are we implementing? Well, I can't say it more, but it's the executive support, executive sponsorship up front that you need to drive SDL within an organisation. We have a project in Westpac, given the name of TOM, stands for Towards One Methodology. This initiative, which we have been engaged with from the very conception, is to put security review processes at each step of the project life cycle, so that when a developer or a project manager wants to follow through what the life cycle or the steps are to implementing a project or an application or a system within Westpac, they have this methodology to follow, and right up in their face, straight away, they'll be able to see what they need to do to provide coverage on information security with what they develop. We're also, as I said before, performing the security application training, and I'll have a quote for you shortly which will be quite interesting from someone who did the training. We're also raising an awareness within our organisation. We actually have one person dedicated to providing security awareness across the whole organisation on information security. That person resides in our security governance team. And awareness also in reports that come out of internal and external audits. Again, code reviews, we have independent third-party organisations conduct those code reviews. We also promote access to MSDN. That allows us, well, we promote it with amongst our developers, because it allows them to keep up to date with the technologies that are security technologies that are deployed, the white papers that come from Microsoft, and we think it's a great initiative that Microsoft provide. The benefits. Education. We derive a lot of benefit from training our staff through knowing that they will be implementing secure processes and procedures in software development, both on an individual and team basis. We notice that the in-process, I've just got a note here about this, the in-process metrics allow us to determine whether or not we're seeing as a project is being developed in the life cycle is catching these any security issues or items that has been overlooked by developers. And when we do the final security review of the FSR, we can also determine that the organisations following the SDL is paying off there as well, with the reduction in the number of deviations or waivers to information security policies. How that works is that we understand it's a real world out there, that you cannot implement projects at 100% compliant to information security policies. So we have a process in place that allows us to provide a waiver to business to let them implement without having the business suffer and sending them back to the drawing board so that they do become compliant with the policy. That training quote there, how'd you like to have that person working on your team prior to training? But he's a good operator now. And also benefits with the executives sleeping easier at night. Some of those regulatory drivers do carry criminal and jail terms for non-compliance. So knowing that we are following SDL, well, to the best of our ability at the moment, and I'm not saying that we're following SDL right the way through, as Adam has explained, that we're only just doing it a step at a time. Lessons we've learnt, executive support, again, I can't stress that enough. It really is critical. You need to get that support from the very, very top. We found that fostering security champions, those people who have I guess a really good understanding of information security, that they like to talk information security even outside of work. If we foster them, we know that within the teams they'll provide an oversight for us and be a contact point for the risk management team, and help us help them implement their applications securely. Having a dedicated risk and security and risk team helps a lot. That's our team. It takes a lot of the burden off the business, but where they're omnipresent, always overlooking the projects. We're very much like a sausage factory where projects come in to our team. We get engaged at the conceptual phase, work with them, following the Towards One methodology process through to detailed design. We conduct reviews and then provide sign-off for when they want to go into implementation and production. And I believe also getting external assistance for SDL training helped us a lot. Understanding the risk-reward balance is crucial for developers, knowing that you can't have a project going in that's going to cover off 100% all the risks. but knowing the balance there for what the business is going to derive with a reward when it implements into production. And don't bite off more than you can chew when implementing SDL. We thought that we could go in and implement SDL and everything would be just absolutely fantastic and wonderful. But yeah, we choked a little bit and took a step back and said, let's take it nice and slowly, and we've done that, and we're seeing the rewards from it now. What we're still learning, again, it won't happen overnight, but it will happen. Expectations, we have to manage them. That a lot of people thinking that with SDL in our organisation that we'll be pumping out secure applications from now on. We realise that won't happen for a while until everyone comes up to speed and we're following SDL. And there's always room for continuous improvement, as the other speakers had mentioned as well. Next steps, we continue to promote the SDL within our organisation and the software development teams, and we're going to also provide refresher training for them as well. With the recruitment process, we're now going to ask security-related questions when we go through an interview process with applicants wishing to work for Westpac. And if you have two applicants, one showing in the interview process, responding to questions that demonstrate their knowledge of information security and IT risk, and the other, to a lesser extent, it's going to make that person shine for us most definitely when we start recruiting. And you might find organisations will be adopting that in the future, apart from just us. As I said, we'd like to formalise threat modelling a lot more and have the consistent use of the tools that are provided. And also to embrace the SDL as a doctrine. But don't get me wrong, it's not like it's a religious experience for us, because it's not. We would like to see the SDL be nurtured within our organisation and see the results of following SDL within the fabric of our security application development. And that brings me to close on this presentation. I'd like to say that I've had a great time here in Australia. Thank you to Microsoft, and thanks to everyone who I've met, who've been very friendly to me while I've been here at PDC. And if anybody does have any questions on the Westpac experience, the customer experience, I'll be on the panel this afternoon after lunch. And now I'd like to hand you over to Graham Elliott to continue with his presentation.
Thanks, David. Okay, so I'm going to spend the next 30 minutes or so going through secure design or security in the design and development phases. Just a quick way of introduction. Graham Elliott, I'm from Microsoft in Australia. I'm a field technology specialist. I help customers use our development products and our development platform in a general way, but also we do a lot of work with customers about how do you take our experiences and build more secure software. So let's start by looking at why do you do security in the design phase. And Mike covered this and David covered this, and it's pretty obvious, right? It saves you money later. It's all about money, right? So it's analogous to the traditional development life cycle. The later you find a bug, the more expensive it's going to be. If you find a design problem in design, it's not going to cost you that much to fix. If you find it in production, it's going to cost you a lot to fix. And we find that with security issues, it's actually worse than that, because if you have a security issue in production that's exposed, you have this concept of risk exposure, right? So it's not just the cost of you actually fixing the problem, right? It's the cost to your business of loss of credibility, loss of market share, that sort of thing. And what we also find a lot of customers are finding, we had a customer recently come to us, communications company, and they've just gone through what Adam spoke about earlier, is a reactive process to basically do some penetration testing on their code and do some security reviews on their code after it was in production. And what they found was that they had some serious authentication issues, or they had some serious least privilege issues on how they'd fundamentally designed their software. And they found the cost of fixing that was actually a lot more costly than fixing any other normal design bug. Design also, putting design in your security and design phase, as Michael pointed out, really forms the basis of security throughout your entire development lifecycle as well. So it starts off with training, education, and resource assignment. So your developers don't come out of university knowing how to build secure code, and they probably don't come out of your competitors' companies knowing how to build secure code either. Or you can't assume they do. Even if you build it into your interviewing process, like David spoke about moving forward, that's a fantastic start. But you need to do this on an ongoing basis. You need to have your designers and architects understand how to build both security features and also secure software. You also need to have your developers understand, how do I recognize what a security vulnerability looks like? During this phase, you also need to look at resource assignments. So Westpac's got their own a specialized security team. They've also got evangelists within each of their development teams. So who in your organization is responsible for security? Who's going to mentor your teams as they go forward? You also want to define the product security goals before you start. What am I after in this product? Do I want it to be secure? And often this is driven by policy, and the way forward is driven by organizational policy. This is good and bad, right? So from a good point of view, it helps with this asymmetric problem. So I'm an organization, I've got to fix every single bug or every single hole in every single application I've got, where, you know, Joe Hacker out there only has to find one of those. Organizational policy allows you to basically apply a consistent method across your applications about how to secure them. The problem with this is often it preempts threat modeling and secure design. And a lot of development teams tend to lean on organizational policy too much. It's the old, you know, it's the classical, I've got a firewall so I'm safe, right? It doesn't work like that. Michael spoke about threat modeling and threat mitigation design, and this really forms the basis of your security design specification. So how are you going to do your identity management? Right? How are you going to do input validation? How are you going to do it consistently across your applications? It's not just about how do you do it in each of your screens, but same as error and exception management, logging and auditing. How do I do it in a consistent manner, right? So that I'm not exposing information, I'm doing it securely, that sort of stuff. So that's the design phase. Why do we do security in the development phase? Even if I have the most secure design in the world, right? If your developers implement it badly, your system's going to fail, right? And most security bugs are actually introduced in the development phase, right? So buffer overflows, integer overflows, SQL injection, etc. They're introduced by your developers, right? They're not necessarily introduced by your design. Some of the focus areas. You can't expect, sure, training's fantastic, don't get me wrong. It basically forms the basis of the starting point for your security implementations within your organization, but your developers need guidance, right? They need standards and principles they can work to and you can measure them against in final security reviews. You need to implement security into your code and peer reviews, right? So Michael spoke about threat models forming the basis of this, right? So you use your threat models to direct and prioritize what you're looking at in your code reviews. But it actually goes a step further than that. You can actually use this as a good opportunity to review your threat models. Are they still valid? Do they need updating? Right? Are there any new threats that have been uncovered that we need to accommodate for? Yeah? A lot of organizations struggle with this at first, which is where Adam's going to talk in his section next about this concept of external systems and how that can be useful. Security tools is a big one. I'm going to do a demo. I'm going to do a few demos of some security tools in Visual Studio 2005. They're really, really cool. The demos are really simple, and I would almost guarantee that most of the developers in this audience are going to spot the security flaws before the tools do, right? And that's a great thing, because the best tool is between your ears, right? You should never look at tools replacing developer competence, right? And you have to understand that you can't just use tools to basically replace your work. What they allow you to do is scale that. So developers or trained developers are very, very good at finding specific vulnerabilities. What they're not necessarily good at is actually finding every single vulnerability within every single line of code. You'll also find a lot of organizations, especially when they take on things like FXCOP originally, if you run FXCOP over your code base at the moment, you are going to have an enormous amount of things, not just security, but design flaws, that sort of stuff. So people go in with the good intention of, yeah, I'm going to run FXCOP, it's going to be great, we're going to, be standards compliant, we're going to be nice and secure, and you just come out with this enormous amount of information, right? So tools don't replace work, and in some cases, they actually initially create more work for you. So that's really just a high-level overview about why we think about security in the design and development phase, or why organizations should. I want to go through now just some quick security design and development principles. And if you're familiar with the Writing Secure Code book, a lot of these will be familiar to you because they're sort of based in the security principles to live by. I've kind of augmented them a bit, changed them. There's a few examples in there, and I've also sort of grouped them into how do you live in an untrusted world? How do you live without admin? How do you reduce your exposure? How do you live with code failure? How do you protect your secret stuff? And lastly, why is it good to be managed? So the first one's this concept of living in an untrusted world. Yeah? And this is all about having a nice, healthy sense of paranoia. Right? The world's evil, it's out to get you. Right? That's a good thought process to have. And the first thing you need to realize about this and about doing security and design in your design and development phases is there's a difference between a security feature and a secure feature. Right? Great example, ASP.NET Forms authentication. Who uses it here? Yeah, quite a few people. It's a fantastic authentication security feature, right? That's firewall friendly, authenticates my users, allows them to log on to my website, right? But if I don't secure the communications channel with something like SSL, it's not a secure feature, right? If I don't encrypt my authentication cookies, it's not a secure feature. If I don't time out my authentication cookies, it's not a secure feature. If I don't use an appropriate identity store and have appropriately strong passwords or strong phases, it's not a secure feature. Yeah? Does this make sense? And even if I do all of that, but I still leave my form open to a SQL injection attack, you certainly don't have a secure feature. And David gave a great example of this, right? Where the company had built a bunch of security features in, and their organization looked at it and gone, wow, fantastic, it's got lots of security features, but none of those are actually secure. So as you're going through design and development, it's not just about looking at this sort of dike you've got and the holes in it and trying to plug those with security features, right? It's also about looking at how do I build every single feature that I have more securely. The next one you'll hear all the time, and Michael brought this up a lot, is this concept of all input is evil. Right? And you don't trust it. Right? The idea is, as Michael said, is always validate data as it crosses trust boundaries. And the biggest mistake I see all the time is using client-side validation. Client-side validation is a fantastic feature in .NET, right? But it's a usability feature. It's not a security feature. Right? A lot of people say, so how do I know what my trust boundaries are? Right? And hopefully if you listen to Michael's presentation, you'll know, right? They're in your DFDs, they're in your threat models. That tells you what your trust boundaries are. That's where you need to be focusing on. Right? And the idea is you need to filter the input as it comes in, especially across those trust boundaries, and then sandbox it, right? So a simple example is parameterize queries in, when you're doing SQL, right? Or when you're doing database access. And linked to this is assuming that all external systems are insecure. Right? Your application and your system is the last bastion standing. The other one you'll hear a lot about, and we've been spruiking this for years, right, is use least privilege. Do you really have to be admin? And it sounds easy, right? We've been saying, yeah, use least privilege, it's awesome, but it's actually not that easy. Before I joined Microsoft, I led a lot of development teams, and I've really had two revolts in my life from the development teams. One of them was when we ran out of pizza and beer one night, and the other one is when I asked the team to all switch off their admin access, right, and use least privilege accounts. Developers hate this. And it's about two things, really. It's about you as a developer running as a least privilege user to start with, right? So all of your users out there should be running with least privilege. The second aspect is actually running your applications as least privilege, right? And only using the services that you need. The reason why this is important is because you will make mistakes, right? You'll miss a bug, you'll type something wrong, you'll take a code sample that's vulnerable to a SQL injection attack. Or maybe not you, but the guy next to you will, right? And if it's not the guy next to you, it's going to be your users. Someone's going to make a mistake, right? And the problem with using administrator is if you make a mistake and a vulnerability is targeted or found in your code, that's bad. If you're using administrator, that's really, really bad, right? The classic example is a SQL injection, right? If you have a SQL injection that's bad, you might expose some, data you don't want to. If you're connecting to the database as SA and you're using SQL 2000, right, it gets really, really bad because I can execute command shell on it, yeah? Linked to this is this idea of designing for separation of privilege, and Michael identified this as well when he went through his identifying the privilege boundaries in your DFD. So there's this realization that when you run your applications, there are high privilege operations you're going to have to do. Make sure you design those out, right, to be separate processes, to be isolated. There's a trust boundary between them, right? So how do we do this? So let's look at practically how do we start by running as least privilege as a developer. And I won't go through this in detail because there's a whole lot of documentation on this. Windows Vista makes it a lot easier for users at the moment. If you're using 2000 or XP, you've got a few options. You can use run as, right? So if you want to install some software, you want to change some configuration properties, you can use run as. The major issue developers find with this is this idea of user profile. So what happens is a lot of applications when they install don't have good user profile awareness. So what they'll do is they'll just install as administrator. When you switch back to your least user privilege account, it's completely useless to you. Right? That's solved by this great little script called Make Me Admin. Right? You can get it off Aaron's blog. Basically what this does is it uses run as under the covers, but it solves that user profile issue because it basically elevates you to admin, installs the software under your user profile, and then drops you back down. Right? Fast user switching is not really an option within organizations at the moment. With Windows Vista, it will be. If you're using domain accounts, it doesn't work on XP and 2000 with domain accounts. Another option is terminal services and remote desktop, as in creating a remote desktop session into your own desktop using administrator, but you still have the same user profile problem of installing applications. The other option, obviously, is to add granular accounts, but this tends to get, add granular positions, but permissions, but this tends to get a bit out of control. From a running applications point of view, we've got this great thing in .NET called code access security. Code access security is really about limiting the access that your code has to protected resources and operations. Really has two modes, right? Your application can be a full trust application or it can be a partial trust application. If you're doing a click once application in Visual Studio 2005, the default's going to be full trust, right? If you're not doing a click once application or click once deployed application, whether it runs in full trust or partial trust will depend on where it's actually run from. And I'll give you a little demo of this in a sec. The problem we've had in the past with full trust, with code access security, is it's actually quite hard to work with from a developer point of view. Right? So what normally happens is most people just build their applications as full trust. It's the default, it's easy, you don't have to think about it. You don't have to do any work, right? So the problem with this, there's two problems with this, right? The first problem is it opens up both your code and your users to potentially malicious code, right? And again, they're running a high privilege, therefore they're going to have issues. The other issue is, if you are running with click once, or click once deployment, basically it doesn't give you a nice user experience, right? They get a nice big text, or they get a nice big big box with a big red X in that says, this application's trying to use potentially unsafe operations, do you want to allow it, all right? And that actually doesn't just happen with full trust. That happens with when you try and use any permission above what's in your sandbox. So what happens is code access security gives you a sandbox, right? And it constrains your code and your operations to that sandbox. The default sandboxes are intranet and internet, and I'll give you a little sample of these. So there's a default set of permissions for intranet. If you try and go outside of those permissions, you might as well be using full trust, right, from a user experience point of view. So the second problem is it's not a good user experience, and you're going to get one of two options, right? Either users are going to get scared, and they're not going to use your application, right? And we see this a lot, actually. And so people just go, well, we'll either force it or everyone just run as admin and just ignore it, right? Or what Michael spoke about, and then they don't really understand what they're clicking on, so they just willy-nilly click it, and you open them up to the first problem, right? So in Visual Studio 2005, we've tried to help developers with this, with two cool little features. One's called the permissions calculator, right? I get asked this all the time. How do I know what permissions? You keep telling me to use least privilege, but how do I know what permissions my application needs, right? So we've got an answer for you now. The other thing is, we get a situation a lot where I built my application, it works fine, right? It works fine on my box, I've unit tested it, cool, let's ship it. As soon as I put it out in the wild, I get all these bizarre security issues, right? Because my security zone's changed. So now we have this concept of IntelliSense in zone, although only for VB.NET developers at the moment, and debugging in zone. So what I'll do is I'll give you a quick demo of these. Yeah, no, I haven't switched it yet. Which am I? DDD. Cool. So I've got the world's most basic app. And if you ever see a partial trust, or if you ever see a security application, right, it actually does one of two things. It accesses files or it accesses the registry. So guess what I'm doing? I'm accessing the registry, because that's what we do when we show security demos. So basically all I'm doing is very, very simple. I click a button. If you have a look, I'm just using the Microsoft Win32 namespace to basically just grab a key, right? Grab a key value of what the registered organization is of the Windows box I'm installed in. Yep. If we run this from here, what I'm doing is I'm running it locally. So I'm actually running it as a full trust application, right? So if I run this, it works fantastically, right? Get Microsoft Corp back, awesome, it's all good. If I, though, run it from a UNC share, right, or if I run it from a website, I'm going to get a security issue. And the reason is because .NET Code Access Security has put me in a sandbox, and it's put me in an intranet sandbox, right? So this is basically saying you do not have access. You need to ask your administrators to grant you, through machine policy, basically the security permission to do the registry permission, yeah? So you see that a lot. You know, I'm a developer, I've just built this thing, and off I go, I try and deploy it, and I get these. So the answer is, well, let's just elevate everyone, and let's just give everyone all the permissions they need, because it makes my job as a developer easy. That's not a good answer, right? So what we've got now is, if I have a look at the project properties, if I have a look at security, I've got this concept of enable click once security settings, right? So if I click on this, by default, I'm a full trust application, right? And if I deploy this through click once, these basically get put in the deployment manifest and then get checked on the client. What I actually want to do is say it's a partial trust client, because I know the way that I'm at the moment using this application is from a UNC share. And I know that that's a partial trust application in the intranet side, intranet zone. So you can see down here, it's got a whole list of my permissions, right? And I can drill down on these and they get a little bit more granular. All right, oh, some of them do. That one does a bit. To basically say what permissions I have within the intranet zone. If I have a look down, you'll see I don't have the registry permission, right? So if I rerun this, now that I've set my zone, okay, what you'll see is I get the same security exception, once it wakes up. Come on, wake up, wake up. Let's try that again. Cool. So if I run that and I click this now, what's going to happen? Please happen. Please, please. Cool. Yay. I get a security exception. Hopefully. Where's my security exception? Come on. Oh, give me a break. Oh, did I? Okay, let me do that again. Dun, 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 dun. Come on. Oops. Yeah, let me just reload that up. Oh, yeah, but I rebuilt it, so I should have. Let me just load that up again. Hang on. So now what this should in theory do is it's going to give me the same security exception that I had when I was running in from the UNC share, because I've told it that I want to run within the intranet sandbox. No, it needs to be debug. Well, for this, it's going to be debug mode, because otherwise I'll just get the security exception. I actually want to step into the code. Okay, let's open that again. Come on. Okay, I might move on. Hang on, it's loading up. What am I doing? Adam, can you restart that virtual machine for me? This thing's dead. I'll come back to that in a sec. Oh, no, hang on. I'll give it one more go. Sorry. Oh, that's a good sign. Okay. Can you restart that virtual machine for me, Adam? I'll come back to that demo in a sec. So what you saw, or what you would have seen, is basically the tools for developing partial trust apps, and I'll come back and show the demo in a sec. The next principle we want to go through is this concept of reducing your attack surface. And the important thing about this is you need to reduce it early, right? So your attack surface is the interfaces that are exposed to an attacker or a potential attacker. And those surfaces that are enabled by default are the most valuable to your attackers, right? And the reason you want to do this early is the same principle about why you want to put security in design, right? Because it's going to cost you a lot less. When you turn off your attack surface, it generally has very large impacts on other parts of your application. Linked to this is the idea of employing secure defaults. So the concept is your users should not actually have to disable features to achieve greater security. And what we found with working with a lot of organizations is that they can actually effectively turn off a lot of their high-risk components of their application or their interfaces or their attack surfaces, and only affect a certain percentage of their users. So generally for, say, example, financial institutions, this is around their high-value transactions, right? For government organisations, only a certain percentage of their partners are affected by certain things. The other general rule you want to go by, if a user has to read something to turn something off or make your application secure, it's never going to happen. So you have to make it secure for them when you start. Yeah. The next thing you have to realize is that code fails. Right? It's a bitter pill for a lot of people to swallow. This really means that your code failure path has to be the most secure. Right? And the biggest mistake I see around this is people logging detailed error information to the client. You can walk all over the internet and you see stack traces everywhere. Right? As an attacker, I can glean information off that. The other idea is learn from your mistakes. So learn from your mistakes. Adam's going to talk about how to build this into your post-production process, right? But also learn from other people's mistakes, all right? So especially with the new duty of disclosure laws, it's very easy to see what your competitive organisations are doing. What phishing attacks have they been vulnerable to? What SQL injection attacks have they had lately? And once you see those represented, look in your applications and learn from them. And Adam's going to talk about building it into your security response plans. Defense in depth we've spoken about for years, right? Basically means as the threat risk goes down, as the threat difficulty goes up. So me as an attacker, if I need to get through more than one layer of defense, right, I'm likely going to give up. And this is best driven by policy. The next idea is protecting your secret stuff. And the biggest thing I've seen sort of in the last 6 months is this idea of treating your storage media as if it was at risk. In the last year, there's been at least 4 very large companies in the US who've had to disclose due to new laws, massive losses of confidential information due to basically losing storage media, losing backup tapes and that sort of thing. Yeah? Got another great example of this. I was working with a government organisation in Australia about sort of 12, 22 months ago. And they'd had this process in place for years where they would basically burn onto a CD every single week a certain number of citizens' records, right? So every week they'd burn this CD and they'd ship it off to one of their partners in government. It wasn't addressed to any name, it was just sent to a department, right? No encrypted data or anything. So we sort of went in there and said, you know what? That's probably a bad idea. You probably should stop doing that, right? This is confidential citizen information. That's not the scary thing. The scary thing is 6 months later, I went back in there and the guy said, hey, you know what? You know, we stopped sending that stuff to this company or this partner of ours. Well, we never actually told them we were going to stop sending it and no one actually complained. So they were basically just shipping out their data, right? It's the old... If you're a Simpsons fan, you would have seen the classic episode where I'm going into the nuclear power plant and I go through these massive amount of security doors and stuff, right? And then I get to sort of the main control center of the power plant and the back door's open and I kick the cat out, right? It's the same concept, right? So, and you need to worry about 2 things. The confidentiality of your data, so who can see it, but also the integrity of your data. The other thing to look at is avoid storing secrets. So your secret is your passwords, it's your hash keys, it's your encryption keys, all right? Avoid storing them. If you do need to store them, store hashes of them. Or if you can't store hashes, take appropriate security measures. As I set this thing up. The next one is this concept by security by obscurity. So a lot of organizations say, I'm secure because no one actually knows what I'm doing, right? So examples are roll your own crypto, hiding security keys in files, relying on undocumented registry keys. I was doing a review of someone's code and that actually written their own blowfish algorithm, right, for encryption. It's kind of a pretty impressive piece of code actually, but I sort of said, well, why did you do that? And they actually had one sort of good reason and one really silly reason. Right? The good reason was when we wrote this 10 years ago, it wasn't really in the platform for us. So we couldn't do it, we had to do it ourselves. The really bad reason was they said, well, if no one knows what security algorithms or crypto algorithms we're using, then no one can hack us, right? And I said, well, for a start, what about your 10,000 previous employees? What about the guys you downsized last year? Do you think they're pretty happy about that? Right? So security by obscurity doesn't work. And if you do need to secure secrets, one of the new things in Visual Studio 2005 is the Data Protection API. The Data Protection API actually isn't new, but its exposure for easy use through the .NET framework is. The last thing I want to go through, and then I'll try and get my demos to work again, is why it's good to be managed, right? So we try and encourage our customers as much as possible to move to managed code. And the main reason is it mitigates the most prevalent security issue that's out there in software today. And that's the buffer overflow or the buffer overrun. But it's more than that, right? It has a rich code access security model. It makes developers' job easier. It simplifies the query model. If you do heavy lifting for developers, they're going to be able to write a lot more secure code. Yeah? There's also a whole bunch of new things within Visual Studio 2005. Right? So I've got my ASP.NET 2 security helpers. I've got static analysis tools, prefast and precop. Sorry, FXCOP. So prefast for C++ code and FXCOP for managed code. So these aren't new tools, but they've been integrated into Visual Studio 2005. I've got my VB.NET My classes. And again, these aren't strictly security things, but they do expose easy interfaces for developers for security reasons, or for security APIs. My verifier verifies my assemblies for common code or efficiency and security security mistakes, C++ safe CRT libraries, and I've also got the GS switch for runtime buffer overflow protection. What I quickly want to show you now is some of these new static analysis tools, and I've just rerun up the demo. And you can see, I finally got my security exception, right, where I've hit the key. So I've basically run this in my sandbox now, and I've got this security exception. So what I get is I get this great new dialog in Visual Studio 2005. One of the options it gives me, and not one I'd recommend you actually use, is this add permission to the project, right? If I add the permission to my project, tell it to restart the debugger, I don't believe so. If you have a look, even though it crashed, hopefully it's added. Okay, you can see it's actually added this registry permission, right? So what it's done is, even though the thing died on me, what it's actually done is it's added this extra registry permission to this sandbox. But what it's done is it's given me a warning, right? And that warning basically says, you've breached the bounds of your sandbox. What this also gives me is this concept of IntelliSense in zone, right? So let's just add a button. And you really only get this in VB.NET. It's not something that you get the debugging in zone in C# and not the IntelliSense in zone. So let's just create a new connection, or a new SQL connection. Whoops. And the first thing you'll notice is when I create that, hopefully everyone can see that, it's actually grayed out a bunch of these methods, right? And the reason it's done that is because it's checked what sandbox I've told the Visual Studio to run in. It's mapped that to IntelliSense and said, which of these methods do I have the right permissions for? And you can see it actually tells me what permissions I need. So for the open, right, I need file IO permission, which is pretty obvious, and I also need an additional security permission, right? So that's something you get with VB.NET. What I want to show you now is some of these new analysis tools. So I'm going to show you two. I'm going to show you FXCOP, which is for managed code, and most of you are probably familiar with FXCOP. I'm just going to show you the integration within .NET. I'm also going to show you prefast, or as it's now called, /analyze. So let's start with my buggy C++ code. So I've got this great little helper class. Does a huge amount of work, right? Does some copy stuff, does some add stuff, leaks some memory. So if I want to leak memory for some reason in an app, I can call this. And I can also create an overflow if I want to. Yeah? Technically, or semantically, there's actually only one thing wrong with this that the compiler itself is going to talk about, right? And that is my use of string copy. So if I have a look at the error list, right, it's actually telling me that string copy's been depreciated. So this is built into the compiler now. And at the moment, it's a warning, and I can actually control in my header files whether or not I display that as a warning or an error. Yeah? So if I just change this to the new safer string copy, rebuild this, you'll see that technically there's nothing wrong with this code, but most of you have probably picked about 16 different actual issues with this code. If I have a look at my error list now, there's actually nothing wrong with it according to the compiler. If I go and turn on in my project properties, my code analysis for C and C++, you'll notice the first thing, it's now /analyze, not /prefast. Right? The next thing you'll notice is when I run this, the first errors I'll get if I'm using beta 2, which I actually did I save it? No, I didn't save the thing. If I turn this on, might help. So if I rebuild this, the first errors you'll see is it's actually telling me that I wasn't meant to use prefast. And I actually didn't use prefast, it's just an issue with beta 2 at the moment. But you'll see a number of things, so ignore the analyze and prefast ones. Right? The next one you'll see is things like, for example, I'm using a single assign operator instead of a double equal, right? I'm also using uninitialized memory. Right? So I'm not doing that, so I could end up with garbage in those. Another one is I'm actually leaking memory, and it doesn't actually know this from the method name, obviously. That's just for the developer if you want to know how to use it. And what it actually does, it actually traces the path of execution for me. So I can look at it and say, this is exactly where I'm leaking T. Yeah? And the other thing I've got basically is I've got an indication of a buffer overrun. Right? So that's just a quick example of what you're going to get out of prefast. And normally, you're not going to leave that up to developers. It'll be in your build scripts to do that. If I have a look at my managed example, I've got this logon form. And I'm using the AdventureWorks demo or the AdventureWorks example. And all I'm doing, I'm basically accepting an employee ID and a password. And when I click log on, I'm going to the database, grabbing a bunch of stuff or grabbing a bunch of information about the employee and just binding it to a data grid view. Right? So again, if I have a look at my project properties, first thing you'll notice is it's completely different for managed code or C++ code. But my code analysis is currently off. Right? So if I run this, what you'll see is technically, again, there's actually nothing wrong with the code. Right? But from most of you have probably already pointed out or seen, so if I run this, it actually does work. It says access denied. If I put in my highly secure password or password, it actually brings back my information. But most of you probably noticed that it actually had a SQL injection flaw in, right? So if I do this, what I've actually just done, all right, is a very, very basic SQL injection flaw, right? What I've done is I've told it that basically select Graham, because I'm doing string concatenation, or where 1 equals 1. 1 equals 1 is always true. And then what I've done is I've put some comments after it. I've put comments after it so I can basically use any password I want. All right? So although the compiler said there was technically nothing wrong with this code, right? Obviously it's got a big SQL injection flaw here, yeah, along with other issues probably. If you have a look at, if we now turn on code analysis, what I'm going to do, I'm going to turn off all of these because it'll pick up all my thousands of naming issues as well. And I'm going to tell it that for a SQL injection flaw, I actually want that to be an error, not a warning. Yeah? If I then rebuild this, right, and look at my errors, we come up, you'll see I get this nice error now, which basically says, hey, you really want to review this query string because you're doing string concatenation and you want to make sure that no user input's going into there. Because if it is, then you're going to be in trouble. All right? So that's just a simple example. Just a quick note, if you do want to try this on beta 2, it's not actually enabled by default on beta 2. You need to do this. This is from the forums. All you really need to do is go to the fxcop directory, create a subdirectory called repository, and drop in a quick XML file. It's just a slight issue with beta 2. Sorry, man? Oh, of course, yeah. Yeah, absolutely. The last thing I want to go through is this concept of security versus usability, right? So you often see, does anyone know what a trade-off triangle is, or an iron triangle? It's a standard development trade-off between cost, features, and quality, I think it is. The trade-off triangles for security is, do you want it secure, do you want it usable, or do you want it cheap? You can have two of those, right? So you can have a usable and cheap system, but it's not going to be secure. Or I can build you the most secure and cost-effective system in the world, but no one's ever going to use it. All right? If you want a secure and a usable system, it's going to cost you a bit of money. Right? And this is the biggest thing, and this is probably the biggest barrier to organizations building secure applications, right? Is actually balancing this trade-off between security and usability. And what it actually does is a lot of people take the pendulum too far, right? And make their application super secure, right? A great example is over complex passwords, right? And it does this, right? It makes it easier to attack level 8 of the OSI model. And level 8 of the OSI model is people, right? So it basically introduces a lot more people attacks versus technology attacks. So that's all I wanted to go through. I'm going to hand back to Adam, who's going to take us through the testing phases now. So I want to thank you for your time and apologize for the demos, but they finally worked, so there you go.
So what I'd like to talk about now is actually testing and security implications, and then briefly go through the final security review as well as security response planning. And when you look at most development projects, you basically have two camps. You've got the developers that think the code's perfect, and you've got the testers that have a completely different view on that. And security issues really, by and large, aren't all that different to many other issues you have in the testing process. But certainly there are some different techniques and processes we need to think about here. What you're trying to do from a testing perspective is make sure that any sort of attack or any sort of vulnerability that you know about is absent. One of the things you can't do, unfortunately, is validate against unknown threats or things that haven't actually been shown yet or been talked about yet. And that's why later in the talk I'll actually go through response planning, because you need to be able to know how you're going to deal with that. The threat model is absolutely key in the testing phase, and I'll talk about that a bit more. And the other thing is, although there's a lot of tools we can use from a testing perspective and a lot of processes that we need, they absolutely build upon the work that was started in the design and development phase. And so you need both. You need static analysis and dynamic analysis, and fuzz testing and penetration testing, which I'll talk through in a second. So the key focus areas in testing. I think the number one thing to think about when you're testing from a security perspective is that if you don't test from a security perspective, I know a whole bunch of people, not personally, but I do know a whole bunch of people who will do it for you. And they'll do it for free, but there'll be some other implications of having them do it. So what you want to think about here is a couple of different processes. One is fuzz testing, and I'll explain what I mean by that in a second. And the second is penetration testing, or I think it's also sometimes referred to as ethical hacking. And I'll talk about that as well. From where you start when you're looking at your testing phase, absolutely the threat model is the number one place to start. That talks about all of your interfaces. It talks about all of your things that can be put at risk, all of the resources you're trying to protect. And then the other thing you want to think about is how you've been attacked before, and how, I guess, similar types of applications have been attacked before. While you're testing, absolutely holistic view is necessary. And really you're trying to challenge the assumptions that may have been made in the design and development phase, which may be a little bit different to normal sorts of functional testing where you're just trying to prove the business requirements have been met. You know, validate least privilege. You know, if something doesn't need to run as administrator, you're absolutely trying to prove that's the case. And also making sure that the default install or the default configuration is as secure as possible. You know, if something's not going to be used, if we mentioned before, the number one user is the bad guy, then you turn it off or you get rid of it altogether. And some of the interesting things that happen here, some of the banks I've been talking to, they've found that by turning off things like international or outbound automatic money transfers, which are primarily used to send money to Eastern Europe or Far Eastern Europe, and not for you know, for criminal purposes, you know, their customers are actually probably, if anything, happier about that. Because I know personally, if I know that money can't be sent into my account, even if someone does get my password, that's probably goodness in many ways. Sample codes and framework, absolutely critical. You know, I think there's a bit of a saying, beware of your giblets. If you've got a bit of code that's being copied and pasted from application A to application B to application C, and then that's got a problem in it, well, guess what? You've got to fix it in 10 places, 100 places, 1,000 places. So I really need to be careful about that. And framework code, you know, in a similar way, if you've got code that you're holding up as here is something that you need to emulate, here's how we recommend you access a database or whatever it happens to be. If that's got a security hole in it, again, you're training your developers to do things the wrong way. So you absolutely want to make sure your test team's looking at that as well. And as I said before, you're done when you know that everything's been mitigated, but there'll be a bunch of stuff you don't know about, and unfortunately that's life. And the goal is to reach as high a bar as you can in the time and the resources you have available. Fuzz testing is an area that there's been a lot more, I guess, interest and discussion about lately, and it's certainly an area that's been proved to be very, very effective from a security testing perspective. And what fuzzing basically deals with is the inherent complexity of parsing complex data. So this could be some sort of file that you're reading in, it could be some sort of network protocol, whatever you have. And it's kind of a variation on the infinite number of monkeys typing the works of Shakespeare. So the concept here is if I just create a bunch of stuff that's sort of vaguely randomized and throw it at the application, eventually something interesting will happen. And we'll talk about it a bit more later. It's a very, very efficient way of finding both security and reliability bugs. Internally in Microsoft, we find about 20% of the bugs are bugs this way. And actually, there was an interesting example recently where we did intentionally put 8 issues into a set of code, and through a whole bunch of code reviews that take some very skilled people spending quite a lot of time just poring over the code, finding everything they can, they actually only found 6 of the 8. And when we looked at doing the fuzz testing, which is an automated process, doesn't necessarily require the same level of resourcing or same level of intense focus by some very skilled people, we actually found all 8 problems within 2 days. So it's certainly something that can be very effective. So how do you actually do fuzz testing? Well, the first thing is you need to think about the entry points to your code, and again, the threat model is going to show you where your interfaces are, and you want to focus in on the interfaces that are either running at higher privilege levels or that are interfaces into something of particularly high value. Some of the banks I've had discussions with look at things like transaction upload for their corporate users, where they could potentially upload their entire payroll. You definitely want to make sure that's going to be pretty secure, so it's something to think about there. And also where you access them from, if it's within your environment or from somewhere remote. And in fact, while you're doing the fuzz testing, you also want to be able to make sure you run the app under App Verifier, which will basically help find any memory allocation problems, any heap management problems, and that type of thing. So once you've got the application and you know which files or network interfaces you're dealing with, basically build a pretty big collection of valid files. You basically want to get files that will deal with all of the valid uses of that application, if at all possible. And then you'll basically make a whole bunch of random changes or semi-random changes to that file, and I'll talk about those in a second. Load it up into the application and see what happens. And to give you an idea here, and for some of our applications internally, we may start with 600 input files. By the time we randomize it, we might end up with 100,000 input files. So we're talking about quite large numbers of things here. And you're only looking for really gross problems. Did the thing give you an access violation? Did it give you some bizarre memory thing? And that's the ones you're going to look at. For network-based applications, you're basically going to make sure you look at both rogue behavior on the client and the server, because you want to test it obviously from both sides to each other. When we talk about tweaking a file, there's a couple of different ways you can do it. There's certainly one you want to look at, which is completely random. You're just going to write a random series of bytes in the middle of the file, move things around, or deal with null termination. But where you've written the application and you know what the file layout looks like, you can actually go and mess with it in a little bit more of an intelligent manner, so that if you know that a certain part of the file deals with I don't know, the length of the entire file or whatever it happens to be, it's got some numeric value, then you can certainly start messing around with those as individual fields, or setting things to negative where they're supposed to be positive or whatever it happens to be. But that again requires, I guess, deeper knowledge of the application. From a network perspective, what you can actually look at doing is just building a thin layer that sits on top of the client or on top of the server and intercepts the communication in flight and does the same sort of messing with that communication. And again, trying to make sure you can deal with some volume so that you're testing as many different cases as possible. So one of the nicest things about fuzz testing is it is really, really easy to automate. When we look at code review is still very important. As Graham said before, the best resource for making sure you miss or you get rid of security issues between your ears. But at the same time, you need to be able to scale out this approach. So certainly fuzz testing is a great way to do that. It doubles as robustness testing. And so one of the interesting things is, say you've run your 100,000 iterations and you found a number of things that are wrong. It doesn't necessarily add a lot of value to understand whether or not a certain crash that was caused is a crash that could be a security problem or whether it's just a reliability problem. You just want to fix it. So you're certainly going to go look at the code and work out if that's a problem that was in multiple places, but it doesn't make sense to do a lot of analysis on exactly how to attack it. Once it's fixed, it's no longer relevant. And one thing you will find is that, because you're testing the code in a large variety of ways, you're going to find a lot of bugs that you might not have found otherwise. There was actually a paper presented at Black Hat on this that I'd recommend you have a look at. And it actually talks about the process around file format fuzzing, and it refers to some tools that you can actually have a look at. So the other side of this is penetration testing. And I was mentioning before, you've kind of got the two camps within your development testing phase. And what we're looking at here is almost playing a game of capture the flags between the developers and the testers, where the penetration test is basically going in and trying to say, well, you said that I shouldn't be able to get access to this resource, or you said that you had this assumption around how I had to authenticate. Anything that you can break, you're just trying to break. And it's absolutely critical tool from a testing perspective, but it's worth understanding, what is penetration testing and what isn't. It's not any security test you could name. It's a very specific pursuit. It's quite structured. I'll talk about that in a second. And for that reason, you're often going to outsource penetration testing to a specialist. So I guess, one of the key things here is because you're taking the attacker perspective, you're going to find bugs that you're not going to find any other way. You're actually taking the attacker's view, so that's going to get you some interesting stuff. There was actually an application level review that I was involved with of an online application a few years ago, where we found not only SQL injection and cross-site scripting attacks, but because we took a look at the application from an external perspective, we actually found the administration console that had been built into this application. And so what had happened is the developer had thought, well, they're taking the server away from me, they're going to put it into the data center. I can't walk up to it and administer it anymore, and he needed to do that because he was kind of changing the code every 3 hours to fix problems that he introduced 3 hours previously. And so this console actually let him, using a static password that was compiled into the application in clear text, log in and start and stop services on the machine and a whole bunch of things. But my favorite was actually enter random script of his choosing to be run on the server as an administrative context. And now nobody else in that organization knew that existed. And that's a hugely dangerous thing to have in an app. So, certainly doing that sort of review, it's going to find things you won't find any other way. And it's a great way to take a message to the management team and also to the developers to say, hey guys, think about this thing. This isn't theory. If we don't focus on testing for these things, we're going to find them. I mean, it's not that hard to find them. So who are we looking at? Who is a good penetration tester? So it's definitely someone who's got a certain level of expertise. Domain expertise about your application area is certainly important, and the type of application is important as well. If it's a smart client app, it's got to be someone who knows how to do penetration testing against that. If it's a web-based app, it's got to be someone who knows how to deal with that, because they really need to know about what's the attack surface, what are the exploit types, all that sort of thing. And it also needs to be someone who's pretty motivated and creative and treating it as, they've got a personal, goal to get into that system any way they can. And, there's no rules here. Anything that gets you in is absolutely okay. But the flip side of that is it needs to be very, very diligent activity, very process-oriented, because at the end of the day, it's that one issue that you miss that will be the one that's used against you. And so this is a great way for you to make sure that, your testing and development processes actually avoided putting this type of vulnerability in the first place. And if they do find things, then it's going to highlight that your development process probably needs to be reviewed. The other issue you're going to have is, of course, because that's a pretty specialized skill set, you can't test everything much as you might want to. But usually, you can pretty easily find out what your priorities are. You can absolutely do this around, what are your high-risk features. So, your threat modeling process would have called that out. From an organizational perspective, you're going to know certain applications are much more concerning than others. Excuse me. When anything changes, that's certainly some time to look at that. And I guess the other thing is, once an area has an exploit found in it, you certainly want to keep lifting rocks and see, you find one cockroach, then you're probably going to find a whole bunch of them. So you certainly want to, look at areas where you're seeing some softness. So from a testing perspective, and I think to some extent, the start of a good security testing is just a really solid testing process. The Visual Studio 2005 Temp Systems release actually has a whole bunch of new stuff that can help from a testing perspective. And this is everything from policies around that are integrated into the development and testing process, through to making sure the bug tracking is centralized, code coverage, which we'll actually do a demonstration of in a second, load and stress testing, which is kind of important because as you start dealing with high workload being applied on top of the application, you start seeing, potentially threading or memory management issues that can be highlighted through that. And finally, App Verifier, which can actually help you find memory management, heap management, so on problems while running the application. So what I've got here is actually just to show a quick demonstration from Visual Studio Team System, some of the testing capabilities. It's basically a component that's being used to send instant messengers out. But what we can do now is actually, alongside this client, this component is actually build a unit test harness. And the nice thing about this is that now this unit test harness, as you can see over here, actually forms part of the overall solution. And what that means is when I'm actually checking this application into my source code repository, I can run this unit test automatically every time I check it in. So you can have policy that says, not only, you've got to check your source code and it's got to compile, it's got to pass, all of the compilation checks and any of the static analysis that you've got, but you can make sure it's got a unit test that was run successfully. And as you'll see in a second, you can actually also use the code coverage results, as input into that decision. So unless you achieve a unit test that's actually exercised the code, you don't get in either. That stops people just writing null tests that didn't do anything. So once I've actually run the unit test against this once, the other thing that we can see here is the ability to actually do some color coding on the code based on whether or not that code was executed. And so even when you're dealing with relatively complex applications, you can very easily see that one section of this up here is in red. That's code that wasn't executed at all. So that's something you want to take a look at your unit test and see what happened with it. Obviously, the stuff through here was executed. What's interesting is in the blue, and it'll actually catch areas where you've got the compound if statements and it fell through on the first condition. And in that case, you want to make sure that maybe there was some stuff that wasn't tested. And when you start dealing with this from more of the overall, overall project perspective or overall application perspective, there's the ability to get summarized statistics on this so that you can actually very quickly at a management level just understand how effective your unit tests are at any given point in time. So certainly, I'd definitely urge you to consider, deeply testing during the security and during the testing phase. Make sure that you're thinking of what the different tools you can use, and look at the appropriate places to use penetration testing. And I've got a reference to a pretty interesting book there that talks to some of the ethical hacking approaches and issues and so on. So once we've finished the testing phase, what we need to do is actually then do what we call the final security review. And this is where you decide, is this application fit to go into production? Have we missed anything? And making sure you're taking lessons learned forward. And so basically, you're going to start looking at the final security review at the point where you've actually basically got the application more or less finished. Only non-security changes finished, as it says there. And while you're certainly going to make the release decision about whether it's okay to go forward with it or not, if you do find a pattern of vulnerabilities, this is also an opportunity to go back and do fix those, but also do root cause analysis and see, was your development process had an issue? Do you need a new process within your design phase or some new tools? So what does the FSR consist of? I think it's important to remember here that the FSR shouldn't really have any surprises. If the rest of the process has been followed properly, really the FSR is just there just as that sort of last check to make sure everything was okay and to identify any process issues that you may have had that need to be resolved. So it starts with somebody from the security team understanding what the status of the application is through interviews. You certainly want to look at all of your bug triaging to make sure that no mistakes were made. At the end of the day, we end up with bugs in code because people make mistakes coding. We end up with bugs in production because things get missed testing. It's only reasonable to expect that the triaging process will have the same issues. And then the other thing you want to have a look at here is certainly any newly reported vulnerabilities that you may not have considered in your process, and also again penetration testing just to make sure you didn't miss anything. And to give you an idea, the final push for a product like SP2, from our perspective, would have tens of people, maybe 45 people on it, and would actually have a number of external security firms involved as well, just to make sure nothing was missed. So certainly, again, urge you to have security as part of your release considerations, and make sure that your management's very involved in this. It can be a very difficult choice for many organisations to actually delay a release when you've found a problem. And what I've found is usually it's only once you've experienced a couple of breaches as a result of that that you'll be more willing to do that in the future. So the last section for section for this session is around security response planning. And the issue is that you basically cannot find every single security problem before you go to production. At the end of the day, somebody will invent a new way to attack your application once you go live, and you'll be forced to deal with that. And so what we're really talking about here is making sure you've thought about the security response as part of planning for product support, and that you know what's the process you're going to follow and who are the resources that are going to do it. To give you an example, one of the banks that I work with quite a lot actually has a process by which when a customer is phished, they will very explicitly not only try to respond to the phishing incident itself, see if maybe the online banking application may have had a problem, which is a little bit more unusual, but certainly make sure passwords are changed or user account IDs are changed, but more importantly dealing with the customer, because that customer's had a breach of trust. And the worst thing that can happen is that you get out of it, you've had a financial loss, but you've lost the customer and their business as well. And so just by making sure that customers feel they're being responded to through these is absolutely critical. So when you're thinking about the response plan, you want to be thinking about who's the team supporting the application. Larger organisations potentially have more problem here because once you start dealing with an application portfolio of 500, 1,000, 2,000 applications, it can be difficult to ensure that you actually have a team for every single application, in every single case. Knowing who to contact if there's an issue, and how you're going to update that application should that be necessary, and that's obviously dependent on the architecture of the application. And finally, you're going to have an overall organisational response plan, and it's absolutely critical that you integrate with that. So what I've done here is basically taken a sample response plan based on the plan that we use in the Microsoft Security Response Center. And just a couple of things that I would urge you to think about through a process such as this. Event identification. How are you going to find the events in the first place? If you are actually looking for SQL, trying to stop SQL code injection attacks, for example, it's quite possible that you could actually detect that somebody was trying to attack you in that way, and then you could just make sure that that was something you were going to be able to deal with okay. Other sources of event identification could be some of your fraud detection systems, where you're trying to do patterns of transactional behaviour and so on. The other issue, I guess, really is around at the back end of an issue, once you've been able to respond and get the application patched and get the customer feeling happy again, is to make sure that you're taking the lessons learned from that. You know, why did this issue occur, and what are we going to do to stop it happening again? Updating best practices, getting better testing tools, and the development and design process. So I absolutely urge you to consider response planning. So that's basically all I had for right now. We're going to do a Q&A session in a couple of seconds. What I would urge you to do is also to come back at 1 o'clock where we've got the panel session on. And if you could, on the way out, please hand out this the paper questionnaire that was provided this morning as you get the book. And additionally, there is a evaluation form on ComNet for the overall session as well. So Graham and David, welcome. All right, we can just take questions down the front if anyone's got any, since we're running a bit late.